Test Analyst, VR Testing. Interview Response Summary. 1. Self-Introduction and Experience Overview. My name is your name, and I graduated from university institution with a degree in relevant field. I bring X years of professional experience in quality assurance and software testing, with particular expertise in mobile, web, and VR environments. Testing experience highlights. Tools and systems, proficient with Jira, TestRail, and Bonsai for test case management and bug tracking. Testing domains, mobile applications, iOS, Android, web applications, and VR platforms. VR experience, hands-on testing with VR headsets including MetaQuest, HTC Vive, and PlayStation VR platforms. Game development engines, experienced with Unity Engine for understanding VR application architecture and performance optimization. Current projects, describe specific projects involving VR or gaming testing. Key responsibilities in current role. Executing comprehensive test cases across hardware and software integration, designing and implementing test scenarios for VR experiences, identifying and documenting complex bugs affecting user experience, collaborating with offshore teams to ensure consistent quality standards to VR video analysis, bug and design, concern identification. When presented with a 1-minute VR video, I would assess visual bugs, texture glitches, clipping through objects, incorrect lighting or shadows, visual artifacts. NIMC 2D, 3D depth issues, stereoscopic alignment problems, depth perception inconsistencies, parallax errors, animation problems, jerky movements, model deformations, incorrect transition states, design concerns, unintuitive user interface placement, accessibility issues, comfort considerations for extended wear, performance indicators, frame rate stutters, loading delays, memory pressure signs, motion sickness factors, disorienting camera movements, visual lag, inconsistent frame pacing. 3. Bisect and issue bisection process involves systematically narrowing down which code change introduced a bug. 1. Identify the affected version range. Determine when the bug started and when it worked correctly. 2. Test the midpoint. Check out the middle. Commit I build between working and broken versions. 3. Classify the result. Determine if the midpoint is working or broken. 4. Repeat recursively. Narrow the range in half each time until the specific commit is identified. 5. Root cause analysis. Examine the identified commit to understand what changed and why it caused the issue. Example: if bug appears in v2.5 but not in v2.0, test v2.2 to 2.3 range, then systematically narrow down to the exact build where regression occurred. 4. Write a test suite for complete scenario coverage. Test suite structure for VR headset pairing scenario, test case ID scenario expected outcome, priority TC 0001, initial app launch with unpaired device, app displays pairing instructions, high TC 002, successful Bluetooth discovery of headset. Headset appears in available devices list, high TC 003, user selects correct headset and initiates pairing. Pairing confirmation request appears on both devices, high TC 004. User confirms pairing on both headset and phone. Devices successfully pair, and connection established. Critical TC 005. Paired device reconnection after app. Restart. Device automatically reconnects without repairing. High TC T06. Connection with low battery headset. Warning displayed, pairing still functions. Medium TC CU7. Timeout during pairing attempt. Clear error message displayed, user can retry. Medium TC 008. Multiple devices in vicinity. User can select specific headset without confusion. High TC 09. Unpair existing connection and pair new device. New device successfully pairs after unpair completion. Medium. TC 0. Connection stability over 30 minutes. Continuous use. No drops or reconnections during normal operation. Hike 5. Test case components without template. A complete test case should include 1. Test case ID, unique identifier for tracking and reference. 2. Title, clear, concise description of what is being tested. 3. Objective, what the test case aims to verify or validate. 4. Preconditions, system state and setup required before executing the test. 5. Steps, detailed sequential actions performed during the test, usually numbered. 6. Expected results, what should happen for each step if functioning correctly. 7. Actual results, what actually occurred during execution. Filled after testing. 8. Pass/fail status, clear indication of test outcome. 9. Environmental details, device type, OS version, app version, network conditions. 10. Notes, by comments, additional context, limitations, or observations. 11. Severity if failed. Business impact if this test case fails. 12. Attachments, screenshots, logs, or video evidence if applicable. 6. Triangle test. Triangle test is a sensory testing method used in quality assurance. Purpose: determine if a difference can be detected between two samples with statistical significance. Methodology: 1. Present 3 samples to testers, 2 identical and 1 different. 2. Testers identify which sample is the odd one out. 3. Results are compared against chance probability, 33.3%. 4. Statistically significant results indicate perceptible differences. VR testing application. Comparing visual quality between game versions. Detecting performance differences. Frame rate variations. Identifying audio quality changes. Assessing UI/UX modifications. Example: testing if users notice graphics quality reduction in a VR game across 3 builds. 7. Priority versus severity classification. Severity: impact on system functionality. Critical: complete system failure, core VR functionality broken, game unplayable. High: major features non-functional, significant performance degradation, game progression blocked. Medium: some features affected, workaround exists, minor performance impact. Low: cosmetic issues, non-critical feature problems, minimal user impact. Priority: business release urgency. IEP 1: must fix before release, blocks testing, affects user safety/comfort. P2: should fix before release, impacts user experience significantly. P3: fix if time permits, minor user experience issue. P4: fix in future release, cosmetic or non-critical. Matrix example: bug severity. Priority reasoning, motion sickness triggering on startup. Critical P1, safety concern, must address immediately. Menu button, visual glitch. Low P3 cosmetic, doesn't affect functionality. Performance drops to 45 FPS. High P2, major UX impact, must fix for release, typo in settings. Text, low P4, minimal impact, can address later. 8. Defect report components. A comprehensive defect report must include 1. Defect ID, unique tracking identifier, auto-generated by system. 2. Title, concise, specific summary of the issue. 3. Description, detailed explanation of the problem observed. 4. Severity, critical, high, medium, or low. 5. Priority, P1, P2, P3, or P4, based on business urgency. 6. Affected component, which part of the system is impacted, VR rendering, UI, networking, etc. 7. Reproduction steps, O. Environment setup, O. Detailed sequential steps to reproduce O. Conditions that trigger the bug. 8. Expected behavior, What should occur when working correctly? 9. Actual behavior. What actually happened? 10. Attachments. Screenshots or video recordings. Log files and system information. Performance metrics if applicable. 11. Environment details. Headset model and firmware version mobile device. OS and version app version and build number. Network conditions if applicable. 12. Reproducibility. Always, intermittent, or unable to reproduce. 13. Assigned to developer responsible for the fix. 14. Status. Open, in progress, fixed, closed, reopened. 15. Comments. Discussion thread for developer and tester interaction. 9. Risk-based testing. Risk-based testing prioritizes test efforts on features with highest potential impact and probability of failure. Implementation steps. 1. Identify risks. Core VR, functionality failures. Safety critical features. Motion sickness triggers, hardware failures. High usage features. Complex integration points. 2. Assess risk level. Probability of occurrence. Impact if it occurs. Combinations that create compounded risk. 3. Prioritize testing. High-risk areas. Comprehensive testing. 70% of effort. Medium-risk areas. Standard testing. 20% of effort. Low-risk areas. Light testing or automation only. 10% of effort. 4. Allocate resources based on risk profile. VR-specific risk examples. High risk. Headset tracking failure. Core VR capability. High risk. FPS drops below 60. Motion sickness inducer. Medium risk. Controller connectivity issues. Low risk. Settings menu appearance. 10. Bug writing and reporting best. Practices effective bug writing process. 1. Clear title. Audio cuts out when switching scenes. Not audio problem. 2. One issue per report. Don't combine multiple bugs in single report. 3. Reproducible steps. Use numbered, clear, sequential steps. 4. Isolate variables. Test on single device/OS combination per report. 5. Attach evidence. Screenshots, logs, video recordings. 6. Quantify impact. Occurs 100% of the time versus intermittent. 7. Describe environment. Exact device, OS, app version, network conditions. 8. Suggest root cause if apparent, but don't overstate bug-raising workflow. 1. Search existing bugs to prevent duplicates. 2. Complete all required template fields. 3. Attach relevant artifacts. 4. Set appropriate severity/priority. 5. Assign to correct team component owner. 6. Track resolution and verify fixed defect template. Example, title, controller haptics non-responsive during game session. Severity, high steps to reproduce. 1. Launch VR app on MetaQuest. 3. 2. Pair controller successfully. 3. Play for 3+ minutes in action sequence. 4. Expected, controller vibrates on impact. 5. Actual, no vibration feedback observed. 11. Technical test case writing skills. Characteristics of strong technical test cases. 1. Clarity. Unambiguous language, avoiding vague terms like verify functionality. 2. Completeness. All necessary preconditions, steps, and expected results included. 3. Measurability. Specific success criteria, e.g., loads within 3 seconds, not loads quickly. 4. Independence. Can execute without depending on other test cases passing first. Automation friendly. Structured to be automatable when appropriate. 6. Technical precision. Includes API calls, database states, network conditions where relevant. Example, well-written technical test case, verify VR hand tracking. Accuracy at distance, preconditions. MetaQuest 3 with hand tracking enabled. Latest app, build deployed. Adequate lighting, 400+ lux. Steps. 1. Open app and navigate to hand tracking calibration. 2. Position hands at 30 cm distance from headset. Perform pinch gesture, thumb plus index finger. 4. Record tracking latency using performance monitor. Expected results. Pinch gesture recognized within 50 mems. Hand position. Accuracy within 2 cm. No jitter in finger tracking. Gesture registers 100% of attempts. Actual results. Filled during execution. 12. Testing app questions to ask and verify critical questions before beginning app testing. 1. What is the minimum supported OS version and maximum API level? 2. What are the target device models and screen sizes? 3. Are there network connectivity requirements or offline capabilities? 4. What are the performance to baselines? FPS targets, memory limits. 5. Which features have analytics tracking? 6. What are the localization/language requirements? 7. Are there backend/server dependencies? 8. What accessibility features must be supported? 9. Are there in-app purchases or subscription models? 10. What is the expected user demographic? 11. Are there security/privacy compliance requirements? 12. What third-party integrations exist? Verification checkpoints. Test on minimum/maximum supported devices. Verify all locale variations. Check network failure scenarios. Validate performance metrics. Test all user permission flows. 13. Blocker scenario. Developer unavailable. Situation. Tester encounters a critical blocker and the developer is unavailable. Response strategy. 1. Document thoroughly. O. Create detailed defect report with all reproduction steps. O. Attach screenshots, logs, and video recordings. O. Include environmental details, device, OS, app version. O. Assign appropriate severity, priority. 2. Communicate effectively. O. Post in Team Slack/channel with link to defect. O. Include summary of impact and scope. O. Flag as blocking testing progress. O. Tag Dev Manager if critical. 3. Workaround investigation. O. Determine if there's any way to continue testing. O. And explore alternative paths through the app. O. Test related features that don't require blocked functionality. O. Document workaround for future reference. 4. Escalation path. O. Notify tech lead immediately if critical. O. Contact development manager if dev unavailable. 2 hours. O. Continue testing other areas while awaiting response. O. Never assume the issue and continue. 5. Follow-up. O. Check for response regularly. O. Provide additional information if requested. Verify fix once developer responds. 14. Practical troubleshooting. Headset. Not pairing with phone diagnostic process. Step 1. Verify hardware. Check headset battery level. Confirm phone battery sufficient. Inspect physical connections and ports. Ensure no obvious physical damage. Step 2. Software state. Restart both devices completely. Power off. Wait 30s. Restart. Update headset firmware to latest version. Verify phone, OS, and app versions are current. Check for conflicting apps. Step 3. Bluetooth specific. Clear Bluetooth cache on both devices. Remove previously paired connection. Forget device. Disable and re-enable Bluetooth on phone. Put headset in pairing mode explicitly. Step 4. Environmental factors. Move away from microwave, Wi-Fi router, interference sources. Ensure clear line of sight between devices. Test an area with minimal radio interference. Move closer if distance is significant. 10 meters. Step 5. Systematic troubleshooting. Try pairing with different phone if available. Isolate issue. Check Bluetooth version compatibility. Review system logs for errors. Clear phone's Bluetooth memory completely. Step 6. Escalation. If still failing, document all steps attempted. Create technical defect report. Provide device logs to developer. Escalate to hardware team. If suspect headset firmware, documentation, screenshot of error messages, device model and firmware versions, list of troubleshooting steps completed, logs/technical data collected. 15. Cross-location bug scenario. Offshore cannot reproduce situation. Offshore team raises a bug that cannot be reproduced by onshore team. Investigation and resolution. 1. Gather additional context. Request detailed reproduction steps with timestamps. Ask for device specifications and environment details. Review logs from offshore testing session. Check for time zone or localization differences. Inquire about network/infrastructure differences. 2. Replicate environment. Test on exact same device model if available. Match OS version and app. Build number precisely. Recreate network conditions, if relevant. Check for regional data or server-side variations. 3. Systematic testing. Execute offshore's exact steps sequentially. Test variations on similar devices. Check for intermittent/timing-dependent issues. Run multiple iterations to catch inconsistency. 4. Possible scenarios. Environment-specific, regional server, device limitation, locale issue, intermittent. Timing-dependent, requires specific conditions, a user error. Misunderstanding of expected behavior. Configuration difference, device settings, permissions, network, OC data issue, specific user account or data state. 5. Resolution options. If reproduced. Escalate as confirmed bug with full details. If not reproduced. Provide comprehensive documentation of test results. If intermittent. Set up monitoring to catch occurrence. If user error. Document expected behavior and provide training. 6. Communication. Schedule call with offshore to discuss findings. Share detailed testing results and logs. Collaborate on potential root causes. Establish monitoring. If bug is real but intermittent, document for team knowledge base. Key principle. Approach with curiosity, not dismissal. Offshore testing often catches real issues that differ by region, device, or configuration. 16. Happy path scenarios. Happy path testing focuses on successful, normal user flows without error handling characteristics. Users follow intended workflow. All inputs are valid. System responds as designed. No error conditions encountered. VR game happy path. Example. Tutorial flow. 1. User launches game for first time. 2. Gets greeted with onboarding sequence. 3. Tutorial explains controls and mechanics. 4. Completes training scenario successfully. 5. Progresses to first level smoothly. Completes first level objective. And 7. Automatically saves progress. 8. Returns to main menu cleanly. Why important? Validates core functionality works, establishes baseline performance, creates expected behavior reference, identifies when things break unexpectedly. Complementary testing, edge cases, invalid inputs, error recovery, network failures, device constraints, permission denials, in FPS, importance in VR. NITS-INI, motion sickness connection. Why FPS, frames per second, is critical in VR. Motion sickness mechanism. User's visual perception expects real-time responsiveness. Brain compares expected versus actual motion. Size. Latency creates disconnect between intention and perception. This mismatch triggers vestibular balance system, results in nausea, dizziness, disorientation, FPS. Impact. 90+. FPS. Smooth, natural perception. Minimal latency. PlayStation VR standard. 72 to 90 FPS. Generally acceptable. Slight latency, noticeable to sensitive users. 60 FPS. Concerning for VR, increased motion sickness risk. Below 60 FPS. unacceptable, significant discomfort, and sickness. Technical reasons. Each frame drop creates micro-stutters. Movement appears jerky and unnatural. Head tracking delays become more apparent. Visual vestibular conflict increases. Cumulative effect after prolonged use. Real-world impact. Users report headaches after 15 to 30 minutes at 60 FPS. 90 FPS enables comfortable 2+ hour sessions. Frame drops mid-session are particularly problematic. Frame time consistency more important than peak FPS. Testing requirements. Monitor FPS consistently, not just peak. Test on minimum specified device. Measure frame time variance. Identify any frame time spikes. Test extended play sessions, 1+ hours. Document any FPS drops under load 18. Difficult colleague conflict resolution. Situation: conflict with difficult colleague in testing team or between departments. Conflict resolution strategy. Step 1. Self-assessment. Understand my role and responsibility in the conflict. Avoid immediate emotional reaction. Consider the colleague's perspective. Identify the core issue versus personality clash. Step 2. Direct communication before escalation. Request private conversation at appropriate time. Use I statements. I noticed we approached this differently. Listen actively to their perspective. Seek to understand their viewpoint. Ask clarifying questions. Step 3. Problem-solving approach. Focus on issue, not person. Find common ground and shared goals. Explore collaborative solutions. Propose specific, actionable compromises. Document agreements. Step 4. Relationship building. Find non-work common interest if possible. Show genuine respect for their expertise. Acknowledge their contributions publicly. Build rapport gradually. Step 5. Escalation criteria. When to involve management. Direct conversation, unsuccessful after 2 or 3 attempts. Conflict affecting team productivity significantly. Colleague becomes unprofessional or hostile. Issue requires policy or process changes. Repeated pattern despite clear communication. Communication example. I notice we had different approaches on the testing strategy. I'd like to understand your thinking. I appreciate your specific strength. I think if we combined our approaches, we could. Specific benefit. Can we discuss? Never. Escalate without attempting resolution first. Complain to multiple people before discussing directly. Document conversation as grievance prematurely. Allow conflict to simmer without addressing 19. Difficult situation with tech lead. Resolution before escalation. Situation. Facing a difficult technical issue or disagreement with tech lead. Approach. Step 1. Prepare thoroughly. Gather all relevant data and evidence. Document the issue clearly and objectively. Understand multiple perspectives. Prepare potential solutions. Know when to defer to experience. Step 2. Request focused discussion. Ask tech lead for meeting time. Don't ambush. Come prepared with clear summary. Show documentation and evidence. Respect their time constraints. Step 3. Present problem clearly. State the issue without blame. Provide data supporting the concern. Explain business impact. Ask for their insight. How have you approached this before? Step 4. Collaborative problem solving. Listen to lead's reasoning. Ask clarifying questions. Propose solutions. Don't just identify problems. Be open to their suggestions. Accept their decision gracefully if overruled. Step 5. Implement and follow up. Execute the agreed approach fully. Report progress transparently. Adjust if needed based on results. Document learnings. Step 6. Escalation only. If lead's decision creates safety/compliance issues. After good faith effort, problem remains unresolved. Lead is unreceptive to evidence. Issue significantly impacts deliverables. You have exhausted collaborative options. Key principles. Tech leads have experience and perspective you may lack. Be willing to learn from their expertise. Seek to understand their reasoning. Show that you respect their leadership. Solve at lowest level possible. Escalate only when genuinely necessary. Example: I've noticed FPS drops below our 90s FPS target during the beach scene. I've collected performance data, share findings. Based on profiling, I think it might be the particle system. Before we escalate, what's your experience with optimization in this scenario? Should we try potential solutions? Interview preparation summary. Key takeaways for success. 1. Deep VR knowledge. Understand motion sickness, frame timing, VR-specific challenges. 2. Technical proficiency. Master test management tools, bug tracking systems, command line interfaces. 3. Problem solving. Approach challenge issues systematically and creatively. 4. Communication. Clear writing for reports, respectful discussions with Team 5. Collaboration. Work effectively with offshore, developers, SE, and leads. 6. Initiative. Improve quality proactively. Investigate thoroughly. 7. Soft skills. Handle conflict professionally. Escalate appropriately. 8. Practical skills. Can execute test cases, write bugs, troubleshoot hardware, software issues. Final preparation tips. Practice explaining technical concepts clearly. Prepare 2 to 3 concrete examples from your experience. Understand VR hardware and development engines. Be ready for practical exercises. Research the company's VR products. Prepare thoughtful questions about the role and team. Document prepared for test analyst, VR testing. Interview preparation. Covers all 19 core interview question topics with comprehensive answers aligned to the role requirements.